So hi, before I tell you the story from yesterday, I can quickly show you in principle how all this Powerwall is working. So now you see on phase number 3 we are exporting 1500 watts, and just simulating by switching on the breaker from the charger, which will then of course be done by the microcontroller. You see how this will now steal the energy from the phase number 3. See, the charger started to operate and it is removing the export power from that phase. And this is the idea, the principle behind the AC charging, the AC Powerwall. So when there is power available, one or two or both chargers can be started to remove some energy from there. Okay, and now to the story of the day. Hi, in this video I want to tell you some experience I made yesterday. So yesterday we have built our AC Powerwall electrical site, and after the building was finished I was trying to make a kind of initial test of the system. So I opened the charger and let the charger do its work, and I was always going there and just checking what was going on. And after 4 hours and already 5.5 kilowatt hours charged into the battery pack, there was still no progress, you know. The voltage kept steady at about 3.35 volts a cell. When I built the battery pack, I was kind of thinking that the cells have been sitting there with around 80% state of charge. So after, let's say, 1.5 kilowatt hours, 2 kilowatt hours of charging, I expected the batteries being full. But that was not the case. So I was kind of wondering why. And the next thing, so after 4 hours I kind of gave up on charging, and I thought, okay, let's try the other way around. Let's discharge the pack so that we have some kind of starting point, right? The first idea was get the starting point from the top and then work our way down. And so I just turned it around and said, okay, let's go the other way. Start from the down, discharge to the bottom, and then we find out the capacity from the down. That was kind of the next revelation of that day. I activated the inverter. And you know, I always thought, the last 2-3 years, I thought that the owner's apartment, which I was trying to discharge our energy, was on phase number 2 on the main building, and some 2 guest rooms in this building have been phase number 1. That's what I thought. So I was running upstairs, opening air condition packs, coming back, and I was watching the smart meter, I was watching the inverter. It was always just showing discharging like 60 watts, right? And I was wondering, what's going on here? Did I do something wrong with the CT, the sensor? Or what's happening? At the end I found out it was completely the opposite way around. So the owner's apartment was connected phase number 1 and the guest rooms to phase number 2. So I went to the main distribution board in the middle of the night, physically, and switched cables and switched phases so that everything was okay there. And from that moment everything was changed and correct. It worked perfectly. The night I was actually discharging the pack completely, and I discharged 150 amp hours or 7.5 kilowatt hours from the batteries, and then we hit the bottom. So actually yesterday after the build, the battery pack state of charge was only 20%, and I thought it was 80. And why is that like this? So that is one of the big lessons also from the first testing. You know, I have a lithium polymer battery pack already on our off-grid system, and on that chemistry the charge and discharge curve is very nicely, you can monitor it by just measuring voltage, because it's kind of steep, right? But lithium iron phosphate, the problem, I don't know if you see it here, in charging and in the discharge curve, between let's say 10% and 85%, this is no curve, this is just a flat, you know, this is a flat line. So it's very difficult by measuring voltage to know about the state of charge of the pack. So it turned out that the small monitor, which I showed you yesterday, I actually did not plan this in this project. I had it laying around. I ordered it once and did not use it. So this one, right? It's one of the most important items now, because this monitor is measuring the power consumption, and by the measuring of the power consumption it is calculating the state of charge. You can enter the capacity of your battery, and then just by measuring power it will then calculate the actual state of charge. So this makes me wonder, because you know our controller, microprocessor controller, will try to determine state of charge by measuring voltage. So even I have planned to use the most accurate analog to digital converter there, which is a 16-bit converter. It might not be possible to do that. So we will see how this will turn out. But it may be necessary to use this kind of monitor additionally to the control. Yeah, then I had another thing I found out. So when I measured the current, DC current from the charger, I never saw more than 25 amps going through the 30 amps charger. So I guess I will have to have a talk with the seller if they really sent me a 30 amp charger, what is going on there. I know they will say, yeah, but you know, it depends on state of charge. But yeah, I started from 20 and charged until 50, so this is actually the area where the charger should put out most of the power. Yeah, these have been the three most interesting points I found out yesterday. Today, unfortunately, it's kind of a rainy day, so I don't know if I want to fully charge the pack, because I would have to pay for it. There's the solar output today will be very low. So let's see, maybe I will wait another day, maybe the weather tomorrow is better. So the next is a full charge until we really hit the top. Then we can read the small meter from the chargers, how many kilowatt hours we pushed into the battery pack, and after we really hit the top, make a full discharge, so that we can then finally establish the real capacity of that pack. Okay, so this was a short video today, and yeah, I hope you find it still interesting to follow my project. Thank you for watching. Please subscribe. We will continue like this, so we will have still more videos to see, because a big part is still missing. This is giving all the system our intelligence. Build a microcontroller, program it, and then run the system completely. Please wait for the next video, and I'll see you next time.